Welcome to Did You Know, the ESCO HVAC Show. We will see you in about 45 seconds or so. Make sure that you are subscribing to our channels, our LinkedIn, YouTube, Facebook. Turn on notifications, and we are very excited to be here with you. It's almost time, about 30 more seconds. Make sure to grab your notebook and pen so you can jot down notes along the way, because at the end of the show, you could have an opportunity to ask our guests questions so we can dive a little deeper into these topics. And here we go. Welcome to Did You Know, the ESCO HVAC Show.
Hey,
How do you like
good
that
afternoon,
intro, Tom?
Thanks for the fun video introduction.
Tom Grunstra, Director of Training for Fujitsu General, joining us today. How are you doing, sir?
I'm doing well, thank you.
Now,
How are you doing, Clifton?
I'm doing great. I'm getting in trouble, ringing the bell. I mean, it's just so much fun. I do get myself in trouble sometimes when I get talking about ductless systems, which is kind of what we're here to talk about a lot today. I personally am a proponent of ductless systems. Now, I talk about the ducted or ductless system that I use here for heating my studio, my wood shop, and my garage. But I also have a ducted system on the rest of the house. And what do I prefer? I absolutely prefer my ductless system for many reasons. But a lot of people don't understand the capabilities that we have with ductless, and especially as educators. Many of us, we get into the classroom, we were really good service technicians and installation technicians. And when we get into the classroom, a lot of time our experience was with ducted systems. So we have a lot to learn to stay up to date with new technologies.
Yep.
And so Fujitsu is a partner of HVAC Excellence, and Tom will be at our conference in March. We're going to be doing some classes. Your class is actually going to be on VRF high efficiency heat pump technologies. That one is going to be on Tuesday from 8:45 to 10. But we're going to have a variety of technical trainers there from Fujitsu to talk about new technologies and innovating our classrooms and making partnerships with Fujitsu to be able to learn about this, and also be able to have material. I know we're going to be doing, Darren's going to be doing a class on cold climate heat pumps, like new inverter technology going into cold climates that work in extremely low, environments. And he's going to be showing how to actually implement that into the classroom. Right. So a lot of really, really good stuff. And I got a new thing. Everyone, let us know where you're joining in from. I'm just outside of Brownsburg. Tom, where are you at today?
I'm in upstate New York.
Okay.
I'm near Albany, New York.
Did you get any of that weather that I've seen up in the Northeast?
Oh, yes, because I was down in New Jersey this week and got about 6 inches of heavy, wet snow while I was there. Yes. But at home, we didn't have any. No.
Wow. All right, so we're going to implement a new thing by request. We've been asked to start adding some more fun things in, so we're going to introduce a new component of Did You Know today, and it's going to be kind of cheesy, but it's going to be kind of fun at the same time. So hold on a second, everybody. HVACR Dad Jokes. All right, Tom. So young technician walks into the classroom. And he says, Professor, I am so excited about everything that I learned in class. I have gotten my ESCO EPA 608 Universal due to your education. I've got my HVAC Excellence Employment Ready certificates. I'm ready to face the world. I think next I'm going to prepare for my state HVAC license. So which one should I do, Professor? And he says, Well, child, you probably ought to apply for all of them. And he says, all of them? Why would I want to do all of them? He says, well, because refrigerants change states. All right, everyone needs a good cheesy dad joke to add once in a while, don't they? And speaking of that, I want you to, if you got some good dad jokes, I've built a little QR with a jot form. Send me some of your dad jokes. I'll try to introduce one every week. And for our lady instructors out there, we've got our mom jokes as well. So send them over and we'll add them in along the way, and we'll all have fun together.
It's just proof that you're a gas to be around.
You know, it's all about having fun and educating an industry. All right, well, let's dive a little bit into why we like ductless systems, why I like them. I know you do, and the capabilities and the abilities that we have with ductless that we're really limited to on our ducted systems. So Daniel's going to bring some slides in for us. Daniel's hanging out in the background, keeping everything flowing for us. We appreciate you being here, Daniel. And so let's talk a little bit about ductless considerations, Tom.
So one of the things that you and I talked about in talking about setting this session up was we talked about why we needed to care about planning, design, application, why it makes a difference. So I cherry picked some slides from some of our different presentations and brought in some things to discuss. And basically, why does it matter where you put the equipment? You know, when you put in a ducted system and it's, put in a new construction house, the ductwork goes in along typical lines. You know, if you're putting in a gas furnace, the return goes here and the supplies go out there, and that's just how it's done.
Right.
And one contractor does it very similar to another many times, right? Whether you have a basement, a crawl space, it's in an attic, there's a typical way it's done. But when you're dealing with a mini split, it can be a little more specific and important. Not that it isn't with ducted systems.
Right.
There's a lot of issues with where ducts are directed and where they work. With a mini split, we actually have some reduction of that, but it becomes even more important. So one of those conversations for us to have is why we put a system where we put it, right?
Absolutely. You know, there's a lot of conversation about air throw when we're designing ducted systems, what type of supplies we're using, what type of comfort we're trying to achieve, and what kind of velocity we're using. And so when we start using a variable speed blower on a ducted system, that all changes as soon as we change speed because our louvers are fixed and we're just moving a certain amount of air in one space. So if I design it for a particular throw and then my inverter reduces capacity, but yet my duct is moving it only in that one fixed direction, I'm kind of limited when I start getting into my reduced capacity scenarios. And with ductless, we have a lot more opportunities to address that, I believe.
Yes, correct. Both the placement of the equipment as well as the opportunity to, for it to adjust itself based on the conditions. And we'll look at a couple of things, and it's literally information that's taken from design application stuff that Fujitsu provides.
Excellent.
So let's go ahead and take a look first at what we need to talk about first, which is surveying the space and measuring, right? Because one of the biggest problems on most applications is improper sizing. DOE says what, 70% or 75% of all systems out there are dramatically oversized, right? 75%. So one of the most important things when planning and sizing a mini split or VRF job is to get it right, because you need it to be the right size so it provides the right comfort in both heating and cooling.
Sure. You know, a lot of these initiatives are to reduce the capacity of a system to begin with. You know,
Get it right so you use less electricity. Exactly.
And so we're becoming a new generation of technicians, which means we need to become a new generation of educator. Discussing these changes that are happening in the industry, understanding that when we approach a situation now, it's not just replacement for replacement. We're not pulling out a 3-ton and putting in a 3-ton just because it was already 3-ton. We're going into that scenario going, all right, do I have the opportunity to re-look at the load on this? And with ductless now, we're doing the same thing. We're just looking at the structure going, okay, let's evaluate this whole structure and see what we can do with this and see if we can better condition all of these spaces.
Right. Good lead in, thanks. And by the way, I noticed that, top of the chat, somebody's from West Texas. I'm hoping they're appreciating the message.
Absolutely.
So fundamentals, we get down to some of the fundamentals, right? Air direction, you're talking about air throw. One of the fundamentals is warm air rises and cold air sinks. So one of the neat things about the most basic wall mount mini split, if it's properly designed, is that it has a diffuser that blows down in heating. It directs the warm air to the floor, provides an even spread of heat across the floor in the room or space. Like you said, however, we also have to know that it's sized right for the room. How do you know what the throw of the air is? It's easier with a quality mini split where you can look this up in the design guide,
Yeah.
because you don't have to do all the airflow calculations to figure
Exactly.
out what that register is going to provide, what the duct CFM is going to be, what the velocity of it is, and at which velocity, at which speed of operation, like you're talking about.
Yeah.
So the additional benefit of this, with at least I know our brand Fujitsu mini splits don't blow cold air, because they limit the capability of the airflow to move through the coil until the coil's hot. So therefore, the only air that comes out is
It's
hot air.
conditioned
Okay.
air. Yeah.
So one of the neat things is the design guide has, and it's called a design and technical manual with Fujitsu.
Okay.
It has charts in it that show in different configurations, heating, cooling, etc., the direction of the air diffusers automatically when it goes into heating. So the automatic direction in heating is for it to blow to the floor. Design consideration, you don't want to put this right over the head of a bed, because in heating, and I
Yeah.
know you like humor, what's going to happen when they wake up in the morning?
Yeah.
They're going to wake up with raisins for eyes.
Yeah. Who's going to be the most miserable here?
Okay, so
Who's got
uh,
the cover over their head and who doesn't?
so where you put this unit in the room makes a difference on how well it's going to heat the space.
Okay.
Okay,
Now that
right,
does change things, because a lot of times when we look at a ductless head, it might be our first instinct to go cosmetically, where is the best place? Especially if I'm a
that's
homeowner,
correct.
I might go cosmetically, where is the best location for this? But as a designer of the system, we actually have to stop and go, well, let's look at functionality and
Yeah,
where is the best location to make
correct.
you the most comfortable.
So take the time to
Mhm.
look at these kinds of things. Take the time to go to the manufacturer's website, look up what the characteristics of the unit are. Don't just go, I need a 12K unit for this size room. Don't
Right.
just pick what I need, right?
Find the actual
Um,
specifications, because they vary differently between the designs of the
Oh,
indoor
but
heads.
different models, sure, different models and different designs. Of course, you're going to have wall mount, you can have floor mount. There's slim duct models, there's cassette models that go in a drop ceiling, and
Mhm.
all those have different airflow characteristics. And every one of those products has its own design and technical manual, which will tell you how the airflow works coming out of those pieces of equipment in
Yeah,
every mode, whether it be heating mode or cooling mode, right?
interesting. Okay.
What's also neat is some of them, not all, some of them actually have a color graphic. Now, the color graphic is
I know
I
that.
put that behind the graph. Okay,
Okay.
it's not like
It's
this in the
overlaid on.
design guide,
Right.
but I did this as an example to show this is a temperature output from one particular model from a few years back of the amount of heat. It's the same model that goes with this graph, right? So this is matched. It's matched to the exact length from both charts, and it shows the temperature of the heat going across the floor. So what's really neat about this is, if I my little pointer will work here, we see that we have the heat coming down here showing 92 degrees where it's red, and 92 degrees running across the floor
Wow,
out 20 feet at 92 degrees on the floor from this model.
that's
And by
intriguing.
the time it gets to its good airflow range of 27 feet, we're
Oop,
still seeing 88-degree air running across the floor.
right. And where do we typically complain about the uncomfort place in a home? The cold floor, right?
Exactly. Right. So this is the value and the benefit a mini split can provide. That's pretty hard to get out of a ducted system, because this is what it does automatically in heating.
Yeah, that is very
Okay.
intriguing. So I have well, I guess it's almost 4-year-old home now, and it's tall ceiling, it's on slab, and it's absolutely miserable in the winter because of the temperature of air across the floor. So being on a slab, all of my ducts are overhead, which means they're only focusing. Because if we think about a traditional layout, I'm going to be blowing my warm air across my coldest spaces, which happens to be like the
Right.
sliding door and the windows. And so it's very hot on the outside, and away from that, the center of the rooms, the floors are extremely cold. So by utilizing proper placement, now we can actually redirect and place that heat in the places where it needs to feel the most comfortable.
Right.
Well, my wife would be happy.
This is definitely warm heat mode, or
Yeah.
warm feet mode, I meant to say.
Indeed.
Yeah, warm heat. Okay.
Yeah.
So interestingly enough, I like to put people in my presentations. This is a please install the indoor unit so that the warm air blows down the walls
Mm.
and it blows it's inside or blowing from the cold area. And we'll talk a little bit more about that with a couple other images when we look at
Okay.
them later. Our goal here is to heat the space, not the people. Because if you blow the air right on the people, they're not comfortable. It doesn't matter whether it's a warm air system, a ducted system, a mini split system. It's you just don't want to try to blow, especially with a heat pump
Yeah.
from any source on people, because in a cold climate, that's going to make people colder, not warmer.
Absolutely. It's the biggest complaint that we get from consumers when they switch from, say, a gas fired appliance to a heat pump that had ductwork that was designed for a gas furnace application. And now all of a sudden we have the air being directly blown onto the consumer. And if the temperature rise isn't what it was with the gas furnace, their first complaint is, I'm cold. Well, the
Yeah.
temperature of the space is really the same. It's just it hasn't been conditioned properly.
Thank you for the compliment.
Yeah, absolutely.
So the reality is that it does take thinking, and what you said there was thinking and planning, and those are the two key things that we need to have contractors learn how to spend the time on, students learn how to spend the time on, so that as they go into the industry, they're going out with the thought, my goal is to make this person comfortable, right? And so what is it that makes people uncomfortable, and find a way to get around that, right? So let's talk about cooling for a second,
Okay.
right? Because we also now know good scorched air to cool air. Good
Hey,
comment,
that's a good one.
Patrick.
Absolutely, Patrick.
It isn't cool air, however. If you then look at the specifications for what these heat pumps put out in cold climates, they're not blowing cool air. They're actually blowing hot air.
Absolutely.
So I don't have that in these slides, but I do have pictures of thermometers of equipment at 12 below zero, and the unit putting out 120, 130 degree air out of a heat pump,
So
right?
part of the bell ringing and getting in trouble that I do in the industry is just a
Yeah,
couple of weeks ago, I had -2 all the way down to -5,
yeah,
and in my workshop, I was out there and I had 80 degrees and I had 115-degree outlet air
yeah.
temperature when I
That's
first
right.
fired it up,
Yeah,
and people don't understand the capabilities and the comfort level. I mean, I prefer working out here in my studio with my ductless system because it's uncomfortable in the house with my ducted. And that's something to think about, isn't it?
so yeah, there's a lot of information that needs to get passed for people to understand, and the difference between a traditional ducted heat pump and a mini split, especially a cold climate situated heat pump,
Mhm.
has to do with that capability of it to produce a higher temperature differential than an 80% gas furnace
Yep.
without a problem, and at cold temperatures, because they modulate. And Clifton, you and I have done a couple things before. We talked about the value of that modulation.
Mm.
When that inverter modulates up, it has the capability of modulating the fan down, which increases the head pressure
Nice.
and increases the comfort. And so therefore, it's cold. It increases the head pressure, increases the differential of refrigeration, and produces hotter heat on the space. And it's just something you can't do with a traditional ducted system. It's not possible for it to control itself that way. Whereas with a mini split, especially the wall mount models, they have the best capability of doing that of any.
Yeah, it's my favorite selection, and you have so much capability with them. I mean, in my space, I have 3 separate areas, and so I sized them individually on those spaces, and so I can have any one room, whatever temperature I want, or all 3 spaces, the temperature that I want.
Right,
Mhm.
right. And I see Marco here has got a great question. Can we expand on proper heat pump duct design? Yes, we can. You're right. It has to be done properly. This
Absolutely.
show is not going to get into the duct design. Though that's that's a much bigger conversation. We could have a lot of fun with that. Maybe we'll do that on another show.
I think
But
so, especially with the solutions that we have with these. When we were talking about these oversized systems that we have, on ductwork that was not designed for the higher
right,
capacity outdoor units that have been installed. Well, what if we rethink that a little bit and go, well, why don't we just get the equipment on our ducted system back down to where it can actually function properly and think about all of our additional spaces that we can now treat separately, sometimes with the
yeah.
same outdoor unit. I won't even get into that one right now.
But Marco, just to quickly respond to you, proper heat pump duct design is proper duct design for
Yeah,
heating.
it's back to the basics.
And so that has to do with the system you're putting in. Right. Do it next. I love
That
it.
sounds like a great follow-up show for us right there.
Thank you for your feedback. We appreciate that.
Yes.
So let's go a step further with not
Okay.
blowing cold air on the occupants, and
Yeah.
let's look at what a wall mount mini split has the capability of doing. This is the exact same model we were looking at the heating design chart for, and the same thing. I overlapped the two. I overlapped both the color graphic as well as the airflow graphic. And this unit has the capability of moving air across the ceiling as much as 40 feet.
Wow.
When you have 40 feet of airflow moving across the ceiling, you can't do that with a single register unless it's making so much noise you won't be able to talk over it,
Exactly.
right? So the capabilities of that wide wall mount model with that the type of blower and design that they have, and it's not moving it with tremendous velocity, it's just moving it with just enough velocity, right? And what's neat is when you look at this, you say, wait a second, if that, and I got to give you a little more information. There you go. The outside air conditions, that's what you really need here. Let me just spin over here and show outside air conditions 95 degrees, okay, 40% relative humidity in cooling mode, right? And it's literally at 95, which would be considered as a design temperature,
Absolutely.
right? By the way, the heating one is at 35, which is below 47 heat
Yeah.
pump design.
I've seen that.
We're actually seeing 60-degree air moving across the ceiling of the
40
room.
feet away.
And then it's dropping down. It's not blowing on people,
Right.
but that cool temperature now is coming down on people because what happens to cold air, everybody? It
Absolutely.
does what? Here, we'll have people chime in.
Yeah. What's
Somebody
gonna
tell us,
happen
what
with
does
our
cold air do?
Sure.
Hot air does what?
And sometimes it takes a minute for our chats to come through, so I'll answer for those. So our hot air is gonna rise, but our cool air is actually gonna settle. And
So we're going to take it across that ceiling
yeah.
where it's usually the hottest, and instead we're going to reverse that inversion layer. We're going to provide something again, unless you've got ductwork that's blowing across from one wall to the next.
Yeah.
And then what's it going to do in heating? It can't aim itself down. So that's the value, one of the great values that you get out of a mini split.
So a much more evenly dispersed heating and cooling zone than what we could think of with a higher velocity, you know, individually ducted system.
Okay, right.
Oh, of course, Howard has to hop in here.
Okay, now we really have some good
Now
humor
we're gonna
going
get
on.
deep. I should have said right up front, are we gonna stay at 1,000 feet, or are we actually gonna get down to the 2 feet, and we'll talk about the lack of heat? Good correction.
Well, Howard brings up the fact that cold does not actually exist. Okay,
The
so
absence of heat.
we'll talk about the cold and time continuum in another session as well, Howard.
Exactly. I
In
have to
fact, I
prepare
think you
for
should
that
write a
one.
magazine article about that.
I think he might have.
Uh, all right. So, what is our occupant of the space saying about cold air?
Yeah.
Please install the units up high on the wall, because guess what a wall mount unit is designed to do? Be installed as high to the ceiling as the minimum specifications will allow. Don't get too close. Make sure you meet the minimum specs to be far enough from the ceiling. And then if it, like you said, if you've got 11-foot or 14-foot ceilings, now you really need to consider where the unit needs to be located. You have to look at that design guide and say, oh, wait a second, if I have a 14-foot ceiling, that airflow may not reach the floor in heating. I need to look at that design guideline. Okay.
Sure, absolutely.
But the goal again is to cool the space and not the people. Right. And again, say yeah, thank you, Patrick. The old absence of heat. Thank you very much. Yes. But wise wording too. I like it. So definitely it's a major factor in comfort if you properly install ducted systems, non-ducted systems, whatever it is. It still takes the thought, it still takes the planning, it still takes application planning. And application is the big word here, applying the product to the project to make your customer comfortable.
Indeed. Yeah, and that probably is one for us to dive a little deeper into at some point. Not going that far into this conversation, but definitely talking about what are, the options, because we always get stuck on, I've got to design a ducted system, got to design a ducted system. And times are changing. And if we look at HVAC systems internationally, we're kind of the dinosaur in the design era. Many of the countries around the world have already moved into the ductless scenarios because you have so much better control and capacity and efficiency. Anytime we talk about a ductless system, we have to understand that I don't have external static pressure putting additional loads and restrictions on the design of my system. And so when we start thinking about application, it's very
Yeah.
important for us to be open minded about what selections of equipment we have now, because we have a lot and we're going to see a lot more going forward.
All right. So speaking of which, there's a lot of different designs. You're bringing up the idea of equipment. Ta-da! You're looking at my presentation in the background, I think. I know you didn't. So, but in this case, the question becomes with a mini split, what controls the temperature in the space? Because these don't typically have a thermostat. Ah.
You mean that's not my thermostat anymore? It's not hanging on the wall. That's it. I thought if I just move this around and put it somewhere else, it would control the temperature in that space.
Not today.
How about that?
So what actually typically controls that in a mini split is an air sensing thermistor. That thermistor is in the return airflow, okay,
Where it should
of that indoor unit. Depending on the design, it's going to be in a different location. If it's a ducted model, it's going to be in the return air. So
be.
it's going to be sampled air coming back from the return, which means that the return and the supply have to be in the same space. So you get this question or this installation where somebody puts a return in a hallway and then the supply in a bedroom or two. It's not going to control the temperature correctly,
Well, especially
right?
in closed
So
space.
again, application, right?
Yeah.
The wall mount is the easiest example when the air comes back in the top of the unit, and we have the return air comes in the top, and the supply air comes out the bottom and either goes across for cooling or it goes down for heating. And the thermistor is sensing that return airflow. That means that where we put this unit right here, I ought to get my little pencil drawing thing out with
Mhm.
PowerPoint, but where we put this unit makes makes the application of how it's going to cool. We were talking about placement, and we'll look at the
Okay.
picture at the end, right?
Okay. Yeah.
But the placement of that unit needs to be where its design needs to be. In other words, if I'm trying to heat a space, if I've got a big, you brought up the fact that you've got a patio, glass patio doors, right?
Yes.
If I put that unit across the room and blow it at it, say, hey, I'm going to blow the heat right at that unit, where's it controlling the temperature from? In the wrong space.
Yeah.
It's controlling it from where it's already
Where I'm
warm.
sitting. Yeah. And
And you said that about the aesthetics. And in one of our presentations, we have a circular diagram and aesthetics and value and cost and payback. And it's got a circle in it of what the value is of not putting it where it looks the best,
hmm,
right? Because we have to talk about this, and
yeah,
it is an issue
absolutely.
that, right, I don't want that thing on my wall.
Right.
I
But
used to
let me tell
sell
you
in I
why.
used to sell in the house. I heard that too many times, right? But the reality is you also then have a conversation of what is your goal, and do you want to be comfortable? Because then we try to put that unit on the wall sideways to the door, so it's in the air and circulating the air like an air curtain
Making a
around that
curtain in
cold
front of it.
door.
Yeah.
And now we have the hot where the cold is. So it's an old adage that I learned: put the hot where the cold is and the cold where the hot is, and that's how you make people comfortable.
Now that's a little bit of a different philosophy, and that's really what we're here to do is to talk about opening our minds to different technologies and the way we can utilize those because many of our students as they're coming out of the classroom, they're leaving the program where they've learned fundamentals. If they haven't been taught this, they may get into the field and go, I wasn't really taught about comfort. I was taught about how the equipment
Yeah,
functions,
right.
but not about
Correct.
how the equipment can actually be applied. So now we're starting to open up a new type of technician. Now we have had roles out in the industry called comfort technicians
Right.
before, but now we're really looking at our businesses going, we're actually very much comfort consultants. We're actually trying to help the homeowner be
Right.
more conscious of the money that they're investing, the comfort that they're receiving, and the efficiency of the equipment that can be introduced into the
Right.
scenario. So a lot of
Yeah.
new variables that some of us older technicians might not be familiar with.
The cheapest thing that you can sell your customer is usually the least valuable, right? For the long haul. And a lot of times it's too easy for people just to put in what's inexpensive, and it has much more value to put in what's efficient and what's good for them for the long haul. And that's you're right. It's a conversation. It's not just this takes a 2 ton, here's a 2 ton
Exactly.
slap,
And
right?
off we go.
Right. So 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 how do we affect the placement of the unit? Well,
Hmm.
we have to think through. Again, it's planning, it's application, it's looking up, it's thinking it through, it's asking questions.
Hmm.
It's really good question asking, right?
Absolutely.
Um, the indoor unit or the air going to it needs to be where, right? And that's a question we have to ask. Where am I going to put it? Ducted. The return airstream needs to be from the same room it's conditioning. Already brought that one up. I
Yeah.
jumped ahead of myself. A wall mount needs to be in the space where the demand is the greatest. And those are the key things. They're simple little things. We're not going to get into much more than that today because it's just the focus of thinking. It's the focus of application. It's the focus of planning so that if there's something like a cold spot, you're there because they're not comfortable. The hardest thing that I've ever dealt with was an application where the equipment had been so dramatically oversized that the people couldn't be comfortable. And I literally got involved with this as a trainer because people were coming to me and saying, how do we fix this design? And I said, well, the first thing you need to do is put a smaller unit in. It's
Right.
oversized. It's in the wrong place and it's way too big. It's going
Right.
to short cycle. It's never going to finish cooling and it's not going to get the air where you want it to go. Right.
Yeah. Take
The
the
unit needs to be moved into the area where it's cold. And the contractor disagreed.
really.
And they told the homeowner that the system instead was undersized and what they needed was a bigger unit. And they took it out and put a bigger unit in.
I was going to say, let's take the fix away from the equipment and put it in front of the application.
So there's a need, like you said, and it's kind of cliche, but there's a need for a paradigm shift in our industry.
I agree.
We have to go through a major shift in thinking. How can we make our customers comfortable and at the same time make use of some of these funds that the government's putting out there to use heat pumps?
Yeah, absolutely. And that is, it's kind of an epidemic in our industry that has went on for so long that we're just finally we got to that point where we've realized that we have to make these changes. And that's the reason we do that. That's the
Yeah,
reason we bring the top educators from the industry in every week to talk about these sensitive subjects, because some of these are very sensitive. And this is
yeah,
one. Because when we look at those scenarios, if I'm the contractor, or even better, if I'm the technician that's being told by the contractor this is the way that it is, and none of us are educated, then we all now have to have some re-education. And that's kind of where we're at. We're all relearning what comfort and efficiency is. So we absolutely have the opportunity now
yeah.
to, when we're having this discussion with the homeowner, going, where are you most uncomfortable in here? That's a great
Yeah.
conversation to
Yeah, and
start.
that is that comfort consultant you're talking about. That's the person who cares about you. And interestingly enough, if a consumer is looking to multiple companies to try to make a decision, uh, the one who tries to help them hopefully will get the job, not the person who's the cheapest price. Right?
Exactly. Yeah. Be the
That's a
difference.
very good point. So there's the pictures we were talking about trying to
Mhm.
figure out where to put equipment.
Okay.
Right? So if we look over here to the left, obviously the windows are open, so the mini split's not running right now. But the best place for this unit is not right over this beautiful picture right here. It's actually as close as we can get it to the wall. I'll push my little lighter on here.
Mhm.
This is okay, but it's not the best. It would be even better if it was over here because in heating mode, when that window wall is cold, that air needs to blow down to the floor, and we need to ask the consumer to move their couches forward about 3 feet so the air can go back across the floor and create a warm curtain coming up in front of that window. And now the room will equalize. But we've got an architect clearly planned this space. And
Sure.
so we are going to be competing with the view of the space, the
Right.
aesthetics of the space. But if the customer wants to add a mini split to try to make this room warmer in the wintertime, it can be done, but it has to be done the right way or it won't help.
Yeah.
It'll help a little, but it won't solve the problem. And we can solve the problem in a space like this. This unit, literally blowing a warm air curtain across this floor behind these chairs, would make this room comfortable.
And
same thing is true in the middle picture. We have that cold wall, and interestingly enough, an incredibly cold fireplace that's going to leak cold air into the room.
yeah.
And if instead we put a mini split similarly in this area here, we have the capability now of blowing heat down across the floor behind the love seat that's there. And it's going to help warm that entire space as it moves out across this beautiful floor, right? And it's going to angle it right out into the room. The picture on the right, that's a toss-up. That's a pretty much tough room to heat and cool comfortably with almost any single system. But that's the kind you spend some time on.
Yeah, for sure. But it makes us rethink the application completely.
And in this case, interestingly enough, one of the ways you could heat and cool that big space with that high ceiling comfortably is use two different mini split systems. Use one at the lower level and one up higher, and run the one up high, blowing air across the ceiling in the summertime for cooling, and blow one down below for heating. And that may, totally different. Could be ducted down below. It could be ducted up above. It could be a wall mount up above. It's a totally, it could be a cassette in the ceiling or a pair of them. And they could both run incredibly quietly and provide that beautiful cool air coming down over that big space. But then they need a different source for heat because the heat would never make it down. But they could still be efficient and make use of the heating system and have that operate that way.
Just rethinking the application once again.
It is. And that could even work from a multi-zone heat pump system where that system could 2 units installed for heating and 2 units installed for cooling have 4 indoor heads. And in the summertime, use these 2 to cool. And in the wintertime, use these 2 below to heat.
Yeah, absolutely.
Same outdoor unit.
It's amazing how many applications that we have with that capability now. Like even like my 3-ton, I have a 3-ton with 4 ports, and I'm only using 3 of them.
Yeah.
So I would have the ability to utilize another head for other conditioned areas.
And if you're not using it at the same time, you're not overtaxing the equipment anyway. It has the excess capacity to manage the load.
Exactly. Yeah, it really makes us think a lot about air moving and comfort, especially when we start looking at some of these custom designs. Because you try to treat any of those with a ducted system, especially when we have all of that glass, all we're doing is pushing the heat with a ducted system, trying to get it back to a return, instead of actually treating that heat in the space that it is with an air curtain.
And you could do this with a ducted system with zoning, but you're not going to increase your efficiency. You're going to decrease your efficiency. Right. Because the zoning on a ducted system, I've had it in my own home, right? I get it. I get the benefits of it. But at the same time, you're now having to oversize a system that can't control itself enough, right, to be in good control. And it just, it is possible. But think of the ductwork you have to put in to make that work between up and down, right? To try to get that to balance and equalize and have returns both up and down and supplies. By the time you're done, your cost will probably double what it would cost to put in a mini split or more, because now you're putting in all rough ductwork and you have to find a place to run it in the space. Yeah. Whereas with the mini split, you're talking about running a couple of pipes, some wire, and a condensate drain.
Especially if that homeowner says, by the way, I want that ducted system to be a inverter as well. And then you have to step back and rethink about the consequences of zone systems with inverters as we're reducing capacity, because we have to. When we reduce airflow, we reduce capacity. So it's absolutely the way I look at our solutions for comfort and efficiency really does come down to broadening our ductless solutions.
Right. And then it comes down to knowledge, right? And knowledge. And so through the last few little slides together, we went over these a little bit, but what is training? Literally look this right up from the Dictionary of Oxford Languages. The action of teaching a person or animal a particular skill or type of behavior. We're hoping that we don't have many animals in our trainings, so we're going to pull that one out.
I don't know. We get a little crazy around here.
But yeah, I mean, what are we doing? What we're doing as an instructor, our goal is to help people with a skill or type of behavior. So what we're doing is we're trying to, in the HVAC world, offer them something that increases their knowledge, that changes them, right? Because if we can change them, it can change their skill level, their attitude, the value to them and for them. In other words, their value as a future employee, the money they can make, the income that they can earn, and the career that they can have, right? So we take and we're trying to turn that caterpillar into a butterfly. It creates an effective change in the thinking of those who are willing to engage in the class. So,
Yeah, Tom, you're so right. That's why we're having these discussions, because there is a lot. I
yeah,
mean, if you think about that, look right here in these solutions that Tom's trying to provide. We're trying to find solutions for skill
yep,
level because we have
correct.
installations that are with technicians that are not properly trained. Maybe not their own fault. Maybe they were never introduced to proper training in the classroom. And
Yeah,
attitude, because when we start having negative attitudes towards poor installations, what changes our perception of the reality of what the equipment can do. And then that value. So we have to relook at our programs and understand that we are making changes in our industry, whether you're prepared for it, whether you want it or not. We are absolutely making significant technological changes. We call this the age of innovation in HVAC and refrigeration. And so we have to be able to produce technicians that have higher skill level, a better attitude towards products, and an understanding of what their value is to the industry and to the rest of the world. And so I commend Fujitsu for stepping up and looking at training from this new perspective.
thank you. I appreciate that. We appreciate that.
Absolutely.
So, if training is the action of teaching a person or a particular skill, and it's creating an effective change in the thinking of those who are willing to engage in the class, and I say willing because
Willing.
anybody who's an instructor out there knows exactly what I'm talking about.
What?
You can get a lot of people in a class, but if
Yeah.
they're not engaged in the class, they're not going to get the value from it, right?
Right.
So, but based on that engagement and that effective change, we can assist with the training. Everything that we're putting into this affects change, delivers results. It improves their current and or future job performance. They become more effective at their role, and they feel safe to work with, service, and sell a product, right?
Yes.
So that this is this is the key thing, right? It is affecting change. It's affecting value. The value of training contractors to students that move into the field is customer retention, loyalty, trust. These are the people that call you back and provide you with future business. And when you do jobs right, even if they're jobs that are not the most cost effective, they're the most cost efficient, but you get referrals, you
Absolutely.
get neighbors, you get family. Again, I sold in the field, and when I was in the field, I had many referral jobs. I probably ended up with the highest number of leads for second, third, and fourth generation leads because of the value of spending the time with people to find the need and fix it.
Mm. I
Okay.
believe that. Absolutely believe in that.
All right, so for me, this is a fundamental. Training creates success. And it's the pathway that any student that we teach has the value of being more capable, fewer callbacks from their work, more self-satisfaction in what they do every single day, and better customer relationships because they're caring about their customer. When you're caring about that customer, it shows in every choice you make, right? So my summary is good training provides contractors and our students a path to success. Right.
Absolutely. And we're going to see a lot of that. We're going to have Fujitsu hanging out with us at the general session on Wednesday at the National HVACR Education Conference. We're going to talk about all of these changes that are happening in the industry. We're going to look at, programs like from the Department of Energy. We'll talk about ways that we can relook at our equipment and our programs and the transitions that we are making in equipment and refrigerants all at the same time. Got to remember, we have a lot of transitions happening all at once.
Yeah, we do.
So we're going to have a general session. We're going to have a variety of trainers at the conference that you can come and meet in person at the booth. We have classes on new technologies. Tom's going to be doing one on new VRV technologies. We're going to be doing one, which is a really good one if you're intrigued with what we're talking about by bringing training into the classroom. We're actually going to be doing a class with Fujitsu on Monday from 8:45 to 10 that's teaching students how to apply. So we call students, we're talking about instructional. It says train the trainer, how to apply mini split heat pumps in cold climates. And we're actually going to be using the instructional material and teaching instructors how to instruct on Fujitsu cold climate heat pumps in the classroom. Because many of us, haven't been introduced into the technology, haven't been introduced into the load calculations and designs of ductless like where we're talking about today. So we're actually going to be in class, instructor-led, talking about this and walking with presentations that you use in the classroom for becoming better teachers of the technologies.
Yeah, the classes this year and the layout of the classes are really, really nice. It's going to be a neat event. There's going to be a lot of content and a lot of stuff that we can gain this year.
And there's still time for you to join us. We've still got, we got 5 weeks, almost, yeah, over 5. Oh, it's getting down there. We're under 6 weeks to
I
the
know.
2024 National HVACR Education Conference. We want you to come hang out with us. We want you to come meet these instructors in person. Tom's going to be there going, hey, let's talk. We're all here to grow together. We want you to have a successful program. We want you to bring successful technicians out of the classrooms, turning students into technicians so that contractors go, I'm looking for successful technicians coming from successful programs. And that's what we're about. We're about bringing all of us together in one place and going, hey, we know that change is difficult, but we're all going through it. Tom, how busy are you right now with training?
I completed a specific one working with my team, right? And I'm one of those that works as a part of the team. So we have a production team, and I'm part of it. And even though I'm the director, I completed a specific new refrigerant training dealing with A2Ls and sharing it with our internal, sharing it with our external instructors. And the very first response I got is, are we going to have one on this refrigerant next?
Yeah.
So it's exponential right now with, refrigerant change, product change, new product development, new training development for all the new products, in addition to maintaining our regular training schedule and support of our trainers in the field. So it's going to be an interesting few years as we move forward on both the residential and commercial product sides.
That's exactly right. That's why I wanted to
interesting.
Incredibly interesting. And we want you to know that we are all in this together. We are all struggling. We are all trying to stay up to date. And how do we do that? Well, we join forces as a community, and we have instructors and directors like Tom Grunstra from Fujitsu.
Tom, no, Fujitsu, that must be me. Here it is.
I know, I've seen it. Bringing us this directly from the manufacturers of the equipment, bringing you the opportunity to learn firsthand, not second, third, fourth, not waiting until you find a piece of equipment that has failed to learn how to make it correct. It's actually starting from ground zero and understanding how things operate, and then understanding how to teach those to the next generation of students and technicians. Oh, I got a lot of reading on this one. You got me awfully excited for this class, Tom. All right. Any questions in the chat? I know we still have quite a few people hanging out with us out there. A lot of people scanning the QR code. So we hope that we see you at the conference. Any last minute things that we want to discuss before we get out of here, Tom?
I'm good. We did a good job. We covered the things that we wanted to when we came in. Definitely time to find out if we have some questions that are related to the subject. We had some good interaction. looking at some of the comments and some of the jokes. I was laughing in the background while you were talking. I had trouble concentrating as a director of training. I understand that because some of the comments are pretty good, you know.
They are, absolutely.
After the comment about animals, you know, we had one that's saying the mini split installations out there weren't installed by humans. So that was the one I was laughing at.
I see that one out there. Oh, Tom, I appreciate you joining us, Tom. Tom's always got a great perspective on what's out here in the industry, and we really appreciate you joining us every week.
My pleasure.
All righty. Well, I think we'll wrap it up for a day. We're so grateful that you all joined us, and we'll see you again next week. Next week, we're actually going to do a train the trainer session for low GWP refrigerants. So one of the hot topics, well, you're just there talking about it. Everyone's asking, all right, what are we going to do about low GWP refrigerants? Because we've all got to get educated on them. So we're actually going to spend some time talking about, as a proctor, as an educator, how do I learn to teach people about these new refrigerants? And so it's going to be a really good one. Yeah, Ty, it is. Absolutely. I love these heated topics. I'm going to have all kinds of hate mail and messages off from this one, but it's okay. We're doing it for the right reasons.
All right. Thank you so much, Clifton. Thank
Thank
you for
you,
inviting me.
sir. We'll see you in a few weeks, and we'll see you all again next week on Did You Know? The ESCO HVAC show.
I hope to see you all there.